Hello everyone, welcome back to the banger of a video. You don't usually see unboxing and review in this channel. This is the Var Tech 936a soldering station. Var Tech is special as I know them personally, and a disclaimer before we start. I have received no compensation as money or the soldering station itself in exchange for this video. This review is completely unbiased, and at the end of the video I'll explain clearly should you even consider a soldering station. Surprise, surprise, this 936a is a well-known industrial grade ESD-safe design, electrostatic discharge safe design. Easy to use, very simple tip replacement. Compatible with various soldering station iron tips. Coming to Var Tech. Var Tech is one of the most popular companies selling here in India since over 30 years, have all sorts of electronics. Test, measurement, production tools you can buy directly from their website. Down in the description. Not an affiliate link, of course. Now, you of course know product is good if the packaging is this good. Some of the features of this soldering station is, it is a 60 watt unit with a 50 watt iron unit. It comes with this packaging which is safe for the environment. Of course, it is repackaged for shipping and it's environment safe. You get the soldering station itself, which comes with this thermocol encasing which will be easing any sort of disturbance which happens due to shipping issues, and you also get this iron in this clean packaging. Of course, this is a 60 watt unit with a 50 watt iron and the case for holding the iron itself. This is an electrostatic safe design, hence you get this ground which usually doesn't come with soldering irons. Other important features include this comes with variable temperature control, and of course the temperature control is really good. It has an input supply of 220 volts to 240 volts AC, and the soldering iron itself has a tip to ground resistance of 2 ohms and tip to ground potential less than 2 millivolts. This total weighs around 1.5 kilos. So apart from this, you do get a user manual and warranty, a sponge which you can use with this for cleaning. I did get one additional tip for this soldering, which is the tip which you usually get with normal soldering irons. By default it comes with this tip, which I will be replacing immediately because this is majorly a kind of a SMD component soldering. So changing the tip is very simple. You just have to remove that, and obviously you also can see the soldering iron itself. This is a heating element. Tight it down, and that's it. So this is actually a linear transformer. It's a heavy base copper wounded transformer which is kind of more durable than SMPS or switching power supplies found in cheap portable irons, which makes a big deal. This actually is the one which brings down the 220 volts to around 24 volts AC, and hence you do get this aviation style connector. So you do get this 5-pin female circular aviation style connector. So the first 2 pins, pin 1, and I'll put this in the video. So the first 2 pins, pin 1 and 2, is for the heating elements, which provides constant 24 volts AC, The 4 and 5 pin is for the thermocoupler or the temperature sensor. Pin 3 is the ground, or the earth pin, which is obviously for
electrostatic discharge, ESD.
To replace it, just push it down here, push it inside and make sure it's tightened. That's it. How do you connect this soldering iron to the station? Pretty easy. So you align the top to this top notch, push it in. You have to put a little bit of force and then you tighten the screw. Until it's completely in there. That's it. I am in great pleasure now because usually soldering iron comes with so less of a wire length compared to this guy, which is like around 6 feet. It's pretty nice. I can go wherever I want and then solder it up and then beautiful. Next up, let us pull out the stand itself. So this is completely stainless steel. This is completely stainless steel. Pretty solid design, I would say. This goes and sits here. You do get a sponge here, which I have pulled it out for wetting it up, and then let's do a round of soldering to understand how good the solder is. Some of the key features of the soldering station are: it has temperature control, it uses sensor controlled precise temperature management. The temperature control range is about 200 degrees Celsius to around 480 degrees Celsius in the dial, and I would say I have used it in between clips and then it is pretty fast. It heats up very quickly and it maintains the temperature. You get this LED indicator to say when it actually heats. Of course, it is electrostatic discharge safe, making it suitable for your sensitive electronic components like ICs and PCBs and expensive microcontrollers. Calibration of temperature is directly in the front with a small adjustment pot like screw, which is really good. I recently bought MPU-6050 for my recent projects. Let us solder the MPU-6050 pins and let's see how good the solder is. Look, if you want your MPU-6050 to give data that actually means something, soldering on a breadboard is just not a handy tip. It's a professional way to do it. The breadboard isn't just a holder, it's a precision alignment jig. Jokes apart, it forces the headers to maintain a true 90-degree angle, ensuring the sensor sits perfectly flush. If your hardware is even tilted by a fraction of a degree, your pitch and roll data are garbage, even before powering the thing on. You don't fix sloppy assembly with code, you do it with fixing your solid foundation. I hear people saying you need to pluck out the module from the breadboard. Here is the actual way. You first plug into your breadboard where you make sure it's 90 degrees. This is where a good soldering iron comes to play. If your iron is set to standard 350 degrees Celsius, you will have perfect solder flow and it will be done in under 2 seconds. Once it's done, you can do the pluck where you pull out the module and then solder the other pins, making sure it is in the right 90-degree perfect angle. Mechanical integrity must be kept in mind. Keeping the pins on breadboard ensures it stays dead while you're soldering and the solder transitions from liquid to solid. If you pull out the sensor when the solder joints are warm, can make your cold solder joints the #1 cause of intermittent sensor failure. So the pro workflow would be mandatory jigging. Snap your headers to the breadboard first, seat the sensor, anchor the tips, finish the run for the other pins, let it cool, let it sit for at least 20 seconds before you pull out so that you don't pull out and make your header skewed. When it comes to buying a soldering iron, stop looking at it as a tool purchase and start looking at it as an investment for your future frustration. A bad iron just doesn't make a mess, it ruins components and makes you quit the hobby. I have intentionally avoided naming specific soldering irons or stations because the right one doesn't depend on brands but your usage. Though using good solders with proper flux like Var Tech or Solderon or similar always helps. If you are ready to stop guessing and start building, I have a high confidence breakdown of how to choose your gear with 3 critical perspectives. The volume of fire. How many joints are you actually pulling the trigger on? The casual. 100 joints here. You only touch the iron few months. A cheap stick just works fine for you. The hobbyist. 500 to 1000 joints in a year. If you are building a project every month, you need a high quality portable iron. These usually have active tips where the heating element is inside the tip itself. They heat up in few seconds and give you thermal recovery fast. The pro. You are at the bench daily. You need a dedicated soldering station. These units have heavy transformers, sophisticated power delivery, and can maintain a precise temperature even when you're sinking heat to a massive ground plane. Perspective 2. Complexity of the mission. It's not just how many joints, but what kind of joints. The easy path. If you're doing only basic through hole components like my MPU-6050 or thin wires, a basic iron works very fine. The thermal demand is low, so the iron doesn't fight to stay hot. The heavy metal path. The moment you try to solder a battery wire or a large XT60 connector like the one I have on my quadcopters, or components which have multi-PCB layers with huge copper plates, a cheap iron definitely fails. It will stick to the board because the copper is sucking the heat out way faster than the iron can replace it. If you are planning on doing a wide variety of work, buy a station with adjustable temperature. It needs to handle high current connections without melting the plastic housing of your connector. Perspective 3. The cheap man pays twice trap. If you have already broken 3 cheap irons, the universe is telling you something. If you have got multiple low-end irons because the tip dissolves, the handles melted, or the heating element have burnt out, stop buying garbage. Quality matters. Cheap iron usually use passive tips which are made of low-grade copper with thin plating. Once the plating fails, the tip is dead. The 3 iron rule. If you have reached the 3rd broken iron, you have already spent the cost of a station. High-end irons use silicone cables which won't melt if you accidentally touch them with the tip. They have auto sleep modes so that they don't burn your house if you kept them on. Now you have got the iron strategy down. Take the right choice, get the right one for you. Thanks for watching the video.